everyone, and welcome back. We are talking tonight about points, lines, and planes. If you are watching this video, congratulations, you've successfully navigated to and opened up the video. If you're sitting there with no piece of paper in front of you, please remember that you can print out accompanying notes that go along with this from the School Fusion page. You do not need to create all of your own notes. So we're going to go ahead and get started. Points, lines, and planes are what we call undefined terms in geometry because they are figures that don't exist in the real world. There's no way for us to, for them to exist because they don't have a shape or a width or a height. So the best we can do is use pictures to represent them and symbols to represent them, but they don't actually exist. We kind of use them to make sense of the world, but they don't actually exist in the world. So the first one that we have is what we call a point. A point is a single location in space. It has neither shape nor size. So theoretically, because it doesn't have a size, we normally would not be able to draw it. But of course, we do need to be able to draw points and draw locations. So we use a dot to represent it. And we can name the dot with a single capital letter. And if we want to name this point, we would call it point A or point whatever capital letter has been designated for it. A line is a series of points that extend forever in opposite directions. So we don't think of a line as being a bunch of points, but it actually is. It's an infinite number of points so closely together that we don't see them as individual points, but as a single line. It has no thickness and no width. Another way to think about that is it has no height. It simply goes on forever. We can name the line in a few different ways. We can name the line itself using a lowercase cursive letter. So I've called this line line P. Please note that this is not the same thing as naming a point. A point we use a single uppercase block letter, and to name a line we use a single lowercase cursive letter. So this letter P is not a point on the line, it's naming the entire line itself. We can, however, also name the line using points on the line, if I could make it show up. So I have here that line P contains point R, point G, and point M. We can name a line using any two of the points that lie on the line. It can be any of the 2 points, and it can be in either direction. So line RM is the same thing as line MR, which is the same thing as GM and MG, or GR, for example. So we can name it using the word line, RM or MG, or we can name it using our points and then using the line symbol on top of those points. So the line symbol looks just like the picture of a line. We need to make sure that we include arrowheads on either side of it to show that it's a line and not a segment, which we'll talk about next video. Okay, and then finally we have a plane. A plane is a flat surface made up of points that extend infinitely in all directions. Okay, so again, it doesn't exist in real life, but we can represent it, and we usually use a picture like this to represent a plane. So it's a flat surface like the surface of your desk or a wall or the floor, for example. And again, we can name a plane in a few different ways. We can name the entire plane using a single capital letter. Again, this letter is in cursive to show that it's not a point on the plane. It is naming the entire plane. The other thing we can do is we can name the plane using 3 non-collinear points on the plane. So if plane K contains the points X, Y, and Z, I could name that plane using any 3 of those points in any order. All right, so let's pause for a minute there. So some related corollaries that stem from the definitions of points, lines, and planes are that through any 2 points, there is exactly 1 line. You need to know that. Through any 3 non-collinear points, meaning points that don't lie on the same line, there is exactly 1 plane. If 2 lines intersect, they will always intersect in a point, and if 2 planes intersect, they will always intersect in a line. My question to you to think about for next class is, what happens when 3 planes intersect in one spot?